एंड बाय स्टूडेंट, तुम इसे याद रखते हो तो अच्छा रहता है दैट द ग्राफ ऑफ कॉस।
Okay. Yeah, Dheeraj. So you are aware of like last time we discussed, right? This one. So you explained me that your relation and functions has started, correct?
Yes.
So what we will do is relations is very easy. Okay. So I will start with functions. Okay. What I will do is we'll start with ITF, inverse trigonometric functions. Okay. Because this is little confusing chapter. Okay. And if you understand the basic of this, it will also help you in your calculus, wherein you will be doing the differentiation, right? And it will also help you in not that yeah, integration, right? So this will help in integration. This will also help you in application of integration and application of differentiation, right? So if you learn ITF properly, it is going to help you in 5 chapters. Okay. Am I right?
Yes.
So in our exam, right, 4 marks will come from this chapter. So let us make sure that we understand everything and complete 4 marks. Yeah. And once we are done with applications, we'll move to relations and functions. Yes. Yeah. So ITF is our target today. So if you look at here, ITF has like definition, range, domain, principal value branch, and graphs. Okay. So when I was at your age, when I was child, I was doing my 12th and all that. So this was one of the chapters I didn't understand. Yeah, like what is the meaning of sine inverse x? How to remember domain and range, right? And how to draw graphs. Okay? So this somehow we will be completing in 1 or 2 classes because this is your fundamental basic. Okay. So initially I'll go very slow. If you want, you can take notes or you will have the recordings as well. Okay.
Yes.
So what is ITF? Okay. So give me a minute. So before understanding ITF, we have to understand what is trigonometric function. Okay. So all these methods, uh, your sine x, right? Sine, cos, tan, cot, sec, cosec, right? And these are like our basic trigonometric functions, right? So what is sine x? So let's deep dive. What is sine x? So suppose I'm drawing a triangle, Dheeraj. If I'm drawing a triangle, So you can say x is nothing but angle here. Right? X is angle. You can also say it is theta. Right? So suppose this is our triangle, right? Give me a minute. Not sure what is happening. Okay. So suppose this is your triangle, okay? And this is your angle. Right? You can say x or theta. Right? So this is base. Suppose my triangle is ABC. One moment. Just a minute. My iPad is. So this is my A. This is my B and C. Right? Suppose this is X. This angle is X. Right? So sine X will be how much? Right? This is a perpendicular. And this is base. So sine X will be perpendicular upon base. Right? Clear? Any doubt here? No. So cos cos of X will be what? No. So it shouldn't be perpendicular to base, right? This is perpendicular by hypotenuse. Cos X will be base by hypotenuse. Right? So what is hypotenuse here? Here this one is hypotenuse. Correct?
Yes.
Suppose you want to get the tan X here. So this will be perpendicular by base. Right? So what I'm trying to tell you right now is, right? So this X is nothing but angle. Right? But in inverse trigonometric function, right, in your ITF, your ITF is nothing but inverse of this. So sine inverse X. Right? It is similar to, right? Suppose I have a function, right? Y equal to fx. Right? So y is a function of x. Hmm?
Yes.
So its inverse will be written as what? Right? Its inverse you can write, right? In place of f, you will be writing f inverse. Right? So here y is dependent on in normal. So what happens is, don't go in sine inverse x. Okay? Right now, what I am saying is, suppose you have a function and that function is like this. Right?
Yes.
So how will we write inverse? We will be writing inverse as y equal to f minus 1, f to the power minus 1 x. Right? So here, this one is nothing but inverse. correct?
Yes.
Okay. So now coming to the fact, I'll not go to the trigonometric function first. First, let us understand the basic. What is inverse? Okay. So, okay. Now, just have some time here. Okay.
Yes.
3 to the power minus 1. Right? This is 3 inverse.
Yes.
This is nothing but 1 by 3. Correct?
Yes.
X to the power minus 1 is 1 by x. Right? But F inverse is not equal to 1 by f. Okay.
Yes.
So what is F inverse? Right? F inverse is a notation. Right? It is not reciprocal. It is a notation to right? What? Notation to what do you call? To represent. Right? Inverse of any function. I'll come here. Yeah. So in the same way, suppose if you're writing sine inverse x, right? It doesn't mean 1 by sine x. Right? It does not mean 1 by sine x. This is wrong. Correct?
Yes.
So this is very, very basic mistakes each and every child does. What people feel, what they do is, suppose it is written, right? Sine inverse and one. It's written sine inverse and sine of theta. So what we write basically?
Theta.
Sine theta. So it doesn't mean ki this and this are getting cancelled. See, ultimately they will get cancelled, right? But its simple meaning is, right? What is simple meaning of this? So this is the inverse of sine theta, right? Sine inverse of sine theta, right? Where sine theta will be anything. It doesn't mean that sine and sine inverse are getting cancelled. Ultimately, they'll get cancelled in some cases. We'll see that at every place it is not getting cancelled. Okay. So ultimately, the answer will be sine inverse and sine theta. Right. Now this and this are getting cancelled. Okay. It is coming theta. But here is a catch. Right? So what is the actual meaning of sine inverse? Right? See, sine x we said. Right? Sine x is the angle between these two sides, this and this. Right? Where x is the, what is this? It is the angle. Right? This x will have some value.
Yes.
Correct? But sine inverse x is not like that. Sine inverse 1 by 2, it's something, right? Now, what basically it means is, right? So, inverse is not angle, okay? It is the inverse of the ratio, right? For which, okay, it is the inverse of a angle uh, x. Suppose they have written like this, right? X. Or not x. Let's assume like some value is given. I'm not coming to exercises. Okay? Now this is written Yeah. Suppose this is 30 degree, right?
Yes.
So basically what happens, right? So what is the ratio, right?
Yes.
So this is the inverse of the ratio 1/2, right? For which the angle is 30 degree. Okay. It means, right? It is 1 and this is 2, right? That's the reason sine theta. Here sine x will be 1/2, right? Correct?
Yes. Yes, sir.
So here x will be how much?
Uh, th- 30.
Sine inverse, no, just
Like,
sine inverse 1/2, right?
uh,
So once you solve this question,
yes, sir.
sine inverse 1/2 is how much?
5/6.
Yeah, so we are not solving it, right?
Uh,
Now I will just see here, right? This is sine inverse 1/2, right?
yes, sir.
So what is the angle for which sine value is 1/2, right?
Yes, sir.
What is the angle? So angle is nothing but sine 30, right?
Yes, sir.
So it is 5/6, right? So what is the value of x? Value of x is 5/6, correct? I'm
Yes, sir.
taking some time because you need to understand the basic, okay?
Yes, sir.
Yeah. So thinking this way, right? Let's assume I have two machines. I have two machine, machine 1, machine 2, right? Now this machine name is heater and this machine name is fridge,
Yes, sir.
right? So what basically happens in heater, what happens? So you will give ice or water here.
Uh,
Suppose you're giving ice as input, right?
yes, sir.
And after heating, what will you get? You will get water,
Hot. Yes, sir.
hot water, right? And this water, when gets cooled, right? Once you're passing it to fridge, right? You're passing this water to fridge, it will give you ice, correct?
Sir.
So here we have like two systems. One is heater, right? And one is fridge. So
Yes,
this heater and fridge are inverse of each other, correct?
yes, sir.
This so if that kind of relationship is true for any function, we can call that those functions are inverse functions, right?
Yes, sir.
So what I'm saying is, if you're seeing here sine x, right? So its inverse will be sine inverse x, right? Its
Yes,
inverse
sir.
is not becoming 1 by sine x, right? So here inverse exists, right?
Yes, sir.
Okay. But for every function, inverse does not exist. Inverse only exists for certain functionalities, certain functions. Okay. Like sine, cos, tan, cots, sec, cosec. Inverse exists only with those functions. Okay.
Yes,
To be very, very precise, What did we learn? We learned, right? Inverse is possible, but inverse does not exist for every function.
Yes.
Inverse exists for some functions, not all functions, right?
Yes.
I'll tell you an example. Right? Suppose I have another two different machines. Okay? One is machine 1, right? And the second one is machine 2. Okay. So this is machine 1. Suppose this is mixture,
Yes.
your mixer grinder.
Yes.
So here what you are doing, you are passing Mosambik here. You drink Mosambik juice sometimes, right?
Yes.
So you're passing Mosambik here as input, right? So this mixture will give you juice,
Yes.
right? But suppose I have another another machine, right?
Yes.
Which is taking as juice as input. This output I am giving as input to another function, right? But so even though it is taking juice, right? It cannot give us mixed Mosambik
Yes.
because Mosambik is a fruit, right? And it is very difficult for a machine to create a fruit, right?
Yes.
So even though it is taking juice, right, it cannot give you Mosambik.
Yes.
So it will not give you Mosambik. So what basically I'm telling, even though there are two machines, right? These two machines are not reciprocal to each other because whatever functions this is doing, right? Whatever function this machine is performing, this machine is not able to uh, reverse it. So
Yes.
here the function will not be inverse, right? So what did we learn? So inverse functions are only possible for certain functions, right? Inverse exists only for some functions and which are like sine, cos, tan, cot, sec, cos x. Only your trigonometric functions. You can write here, right, that for only trigonometric function inverse exists. Okay. Any doubt until here? I'm just
No.
giving you basic. Okay. I'm not
Yes.
teaching you anything right now. Okay.
Yes.
Now, second thing is like, suppose diagrammatically, how will you refer? Suppose this is my set A, this is set B, right? This is a 0.7, right? And this is 0.10.
Yes.
This is 10. Okay. Now, f is a method where f is a function from uh, A to B.
Yes.
Okay. This is my A, this is my B. Okay. And f is a function from A to B. Right? So, this is a function, right?
Yes.
Function means what? It is 1, 1, right?
Yes.
A function is said when each object has an image, right? And from A to B, there will not be any leftover objects here, correct? So
Yes.
this is 1, 1, and this is on 2 also, right? On 2, right? And
Yes.
you call these relations as bijective, correct?
Yes.
So if f is a function from a to b, it means it should have 1, 1 and 1, 2. Right?
Yes.
Now, in the same relation, right, when f inverse will also exist, means there should also exist one behavior like this, right?
Yes.
So what I'm saying is, you wrote here, no, Dheeraj?
Yes.
F of A equal to B, right? It is a function, right? It means I can safely write, right? What I should be able to write? First, f of A, or you can say f of 7, right? F of 7 is 10, right?
Yes.
Now, there should exist a relation such that f inverse, right? F inverse 10 is equal to 7, right? See here,
Yes.
10 is an image of 7, right? So this is a function, right? If 7 is also an image of 10, if reciprocal is also true, then only this function will be considered as inverse, correct?
Yes.
Let me know if you're not understanding.
I understand, sir.
Okay. So what I'm telling is, right, you have two sets, A to B, okay? This is 7, this point is 10.
Yes, sir.
If 10 is an image of 7, right? So it is known as function A to B, right?
Yes, sir.
When its inverse will exist, right? F inverse B to A will also be true when
Yes, sir.
f of 10 is equal to 7, right? So
Yes.
both the relations should be true, correct?
Yes.
So you're getting my point, right? One
Yes.
question comes from this concept in your exam,
Yes, sir.
right? So here, what did we learn, right? So this all inverse trigonometric functions should be on 1, 1, and they should also be on 2,
Yes, sir.
right? 1, 1 and on 2 should be there, okay?
Yes.
So far
Yes.
I'm not teaching you anything. I'm just guiding you to understand what is a function and what is inverse function, okay? So
Yes.
inverse function will only exist when right, inverse image is a pre-image of this, correct? Means 7 is the image
Yes.
of 10, 10 is the image of 7. In that case, it exists. Now let us see one example, right? Here only. So this is my A, this is my B, okay?
Yes.
A, B. Now I have 3 here. I have 7 here. 3, 10, 20 things. Okay? Now let us do this. So here f is a function from A to B, or f is a relation between A to B. Is it function or not? Check, right? I'm just checking whether A to B is a function or not. For A to B, I have to see, right? For each element, right? It should be 1, 1.
Yes, sir.
So 3 is an element, 3 here. In A, 3 is there. In B, 10 is there, right?
Yes, sir.
So 1, 1 is completing, right?
Yes.
Is it on to?
No, sir.
Why not on to? Can you give your reason?
The 20 is.
Yeah. So this is not on to. Right? Yeah. So far, any doubt?
No, sir.
So every inverse trigonometric function should be a function. Okay.
Yes, sir.
So it inverse. Suppose now I'm telling this, right? I'm writing F inverse, right, from B to A. Is F inverse existing here or not?
It exists.
Think little. So what is the function? Function is, right? It should be 1, 1 and on 2, right? So see, 10 has an image as 3, right? But 20,
Does not have unit.
20 is one element which does not have any image here, right?
Yes,
So what I'm saying is F from 1 to B, right? It is a function, right? So here whatever you told, right? If it's 1, 1 and on 2, it is 1, 1 also and all on 2 also. I'll tell you how it happens, right? This is very important that we understand this concept. Okay. See there is A, B. Okay. A, B. Now this has two, 3 elements. Okay. And 3 images. Okay. Suppose this is 3, 4, 5. Right? This is 10, 20, 30. Right? Now what I'm saying is 3 has a image 10. Right? 4 has a image 20. Right? And 5 has a image 30. Then see it is 1, 1. Right? Because every element has a image here. Right? So 1, 1 is there. 1, 1 is there. But onto means, right? In A, our function is like this, right? F is a function from A to B. Right? A to B. Okay. So in order to become onto, right? A should not have a element which does not have image. In A, you should not have an element which will not have any image. But here all the element have image, correct? So it is onto also. Clear?
Yes.
I'll come to 3 variations of this. Okay. A, B. Suppose this is 3, 3, 4, 5. 3 has an image, 4 has an image, phi has an image. Okay. This is 10, 20, 30. Okay. Now there is another element, which is 8. So now tell whether it is 1, 1 or 1, 2.
Yeah. It is 1, 1. But it's not on 2.
Yes. Let us see what is 1, 1 on. One means right, A to B is on to if each element of the codomain B has a pre-image of A. Right? This is not 1, 1, Dheeraj. How it is 1, 1? Right? See, 3 has image, 4 has image, 5 has image. But this guy is not having any image. Correct? So it is not 1, 1 itself. If it is not 1, 1, then there is no point in going and search for on 2. Right? So it means here the relation from A to B, right? Here the function f from A to B, okay, it's not a function. F is not a function, right? So its inverse will also not be a function. Any doubt? No, if you have any doubt, just tell me. Okay. So see, in this case, we have f is a function, right? Here f is not a function because it is not 1, 1, right?
Yes, sir.
Therefore, what we can write? We can write, therefore, f is not a function because it is not 1, 1. Right?
Sir.
Now, third example. Suppose you have A and you have B. A, B. And suppose I have 3 elements here. This is 3, 4, 5. Right? And I have 10, 20, 30, 40. Right? Now this 3 has an image 10, 4 has image 20, and 5 has image 30. So it's a
Yes,
1, 1, 1.
Yes, sir.
It is 1, 1. Fine. But it is not on 2.
Yes, sir.
Because this B's 40 is not the image of anyone.
Yes, sir.
So it is not on 2. It is not on 2. Right? Therefore, f is not a function. Right?
Yes, sir.
So if it is not a function, it will not have
F
inverse
is-
function. Right? So f inverse is not possible. Getting my point? Right?
Yes, sir.
Okay. So now function part is clear for you. We'll move on to inverse. Okay?
Yes.
Give me a minute. Just
Yes, sir.
now I will move to so what did we learn? Like every function does not have inverse, right? So very important, these notes you can take. I'll put you in WhatsApp also.
Yes, sir.
So we learned every function does not have inverse. Does not have inverse. Okay. And the second point we learned is F inverse is not 1 by F.
Yes, sir.
Right? F inverse is not 1 by F. Okay. So what is F inverse? F inverse is a notation.
Yes, sir.
So F inverse is symbol or notation. Right? Notation to represent inverse.
Inverse.
Right? Inverse. Okay. And inverse of a function when it exists, right? When the function is 1, 1 on 2, right? Then only its inverse is possible. Okay. One questions will come from here, right? So let me explain you now. Okay. Inverse. So function should be 1, 1. Function should be on 2. Right? F is 1, 1. F is on 2. And together these are known as bijective. Bi means 2.
Yes, sir.
Okay. And F is strictly increasing or decreasing.
So what?
F is I'm coming to inverse now.
Okay,
I'm
sir.
coming to inverse trigonometric function. The properties of inverse trigonometric functions are, right? The function is 1, 1. Function is on 2. F is strictly increasing or decreasing. I'll explain.
Yes.
F is strictly increasing or decreasing. Okay. And the fourth property, these things are not available in exam. Okay. But it comes in JEE exam also. Okay. What I'm asking is if we draw a line parallel to x-axis, right?
Yes, sir.
I'll explain you very nicely. If we draw a line, right, which is parallel to x-axis, parallel to x-axis, right? Then what will happen? It must,
Not intersect with more than one point.
yeah, it must cut at one place only. Okay.
Yes.
Last year board also this question came. It must cut the graph, right? Means the line. It must cut the graph only at one place. One point. Okay. These things are the properties of inverse trigonometric function. Now I'm coming to you, explain you. Okay. So f is 1, 1 and 1, 2 we understood, right?
Yes.
So how do we draw graph x-axis, y-axis like this, correct?
Yes.
So what I'm saying is, suppose there is a curve like this, graph who is going up and down and up. Okay. So I couldn't make it properly. Give me a minute. Yeah. Draw a graph like this. Suppose I have any graph. Okay. I'm just drawing y equal to sine x now, not sine inverse. Okay. How will we draw the graph of y equal to sine x? Right? So here y is dependent on x. So let us draw the values of x and y. Okay. This is value of x, y. What values we can take? Let's take 0 degree. Okay. So if you're taking x equal to 0, right, we can also plan for like 0, 90, something like that, right? 180. So if anything to do,
No, sir, I just close the door.
okay. So what I'm saying is I'm planning to draw the graph 0, 90, something like that. Okay. So when x is 0, what will be the value of this, Dheeraj?
Zero.
Is put 0. So this is nothing but 0. So y is also 0. When you are putting value of x as 90 degree, so y will be sine 90 is equal to 1.
Yes.
So basically the curve will be like this. Suppose it is, you are taking 0 and then 90. This is 0.
Yes.
So one point is 0, 0 here. One point is 0, 0. The other point is 90 and 1. So this is pi.
Yes.
And this will be 1. So curve will be like this, right? Then at 180, here will be pi. This is pi by 2, sorry, not pi. This is pi by 2, no? 90 degrees. Here will be pi. Means what I am telling is when your value is 180, right? Sine 180 is how much? I mean
0.
y equal to sine 180. Okay. How much is sine 180?
0.
No. Zero. Then sine is 0. Okay. So now it is pi. Right? So basically your curve is going like this. It went here, right? And it will come down. Correct? Again, the curve will go like this. One complete oscillation. Right? This is the graph of sine. Right? But we have to also select the negative things, right? Negative values of x. See, I took this quadrant, right? In order to see this quadrant, what I have to select? Right? I need to take minus 90. Right? And minus 180.
Yes.
So minus 90 means minus pi by 2. So you'll see what will happen if you're putting y equal to sine my x equal to minus pi by 2. Sine minus theta is how much?
Minus 72. Yeah.
Minus sine theta. Right? Sine minus theta is minus sine theta. It means this will go to minus 1. Right? So where will be minus 1 here? Minus 1 is here. So minus 1 is here and pi by 2. So the value will come somewhere here. Let me erase it. This is minus pi by 2. So this is the point. Now the curve is going like this. Again sine minus 180 degree. This is 0. This is minus 1. Right? This is again 0. So at this point, this is your minus 180 minus pi. When it is minus pi, the value is here, right? Not here. 0, correct?
Yes.
So the coordinates are like this. Now the coordinate is here. Okay. So your curve is going like this. So ultimately the graph of sine theta will be looking like something like this. One minute. So this is one. and this is the other one. Right? Correct? Again, if you just further draw it, it will keep on moving like this. Correct? This will keep on moving like this. Right? So what did I say? Now I have to select a straight line. Right? Not here. Let me draw it very neatly for you. Okay. I am drawing the graph of sine theta or sine x. We'll just draw it like this. Went, came down, went up. Again, take it. Give me a minute. Now I'm drawing like this. It's going up. When you draw, what did we say here? One property. If you draw a line parallel to x-axis, it must cut the graph only at one point. Right? So let's assume if you're drawing a line, Dheeraj, from here, this line is parallel to x-axis. I'm drawing a line which is parallel to x-axis. Okay? And it should cut the graph only at one place, correct?
Yes, sir.
But this line, which is parallel to x-axis, it is cutting it at multiple places.
Yes.
One is here, one is here, one is here, one is here. Right?
Yes.
It means what? Right? It means this y equal to sine x graph is there, no? Is not a function because it is not 1, 1. It is not 1, 1.
Yes.
It is many 1. Correct?
Yes.
In one straight line, right, the graph has multiple points. So definitely it is not 1, 1. Right?
Yes.
Then it is not a function, right? But I'm just trying to explain, right, why do we need inverse function for sine, even though sine x is not 1, 1, right? So what happened is, not we, not you, maybe our ancestors or those people who were actually using mathematics at a deeper level, right? They figured out that they need inverse of sine at some place. Okay? Correct? So they need inverse of sine at some place in physics and chemistry or in mathematics also, right?
Yes.
So they said, right, we will have some mechanism to make it inverse. Okay. So what they decided was, right, fine. In this region, in entire region, y equal to sine x or whatever, right? This function is not 1, 1, right? But let us reduce its domain, right? So let us reduce its domain, right? And we only will take from 0 to pi by 2. Okay. We'll take only from 0 to pi by 2. At 0, function was like this, and pi by 2 like this, right? So this is 0, this is pi. Right? So this will be minus pi. Right? So if you select this function at pi by 2, right, and minus pi by 2, right, so you will get it something like this. Now I am restricting this function. We are not taking the entire range. Okay, we are only taking between 0 to pi by 2 and this side minus pi by 2. So basically we are trying to see how is the behavior between minus pi by 2 and pi by 2, right? Both included. So let me explain you. So function is going like this, right, Dheeraj?
Yes.
Right? And function is going like this. Right? So between minus pi by 2 and pi by 2, this is like this. I'm restricting this. Okay? This is at pi by 2 and this is at minus pi by 2. Okay? Correct. Now if you draw a straight line parallel to x-axis, this is x-axis, correct?
Yes.
This is our x-axis. So if you draw a straight line, that will cut this graph at only one place, anywhere. Suppose I'm drawing this line, one line parallel to x-axis. So now it is cutting only in this place, correct? No?
Yes.
And below also, if you're drawing a line, a straight line which is parallel to x-axis, so it is also cutting this graph at one place. Okay? So now, even though sine x, y equal to sine x, graph was not a function, right? Even though it was not a function, right? When we restricted between minus pi by 2 to pi by 2, what happened? It became a function, right? That's the reason, right? You must have heard what it is domain, what it is range, right?
Yes.
So when you restrict the x-axis and y-axis of any function, right, you will get the principal axis. You will get the domain and range. Okay,
Yes.
got it now?
Yes.
So y equal to sine x is a function when we have restricted it between pi by 2 and minus pi by 2, correct?
Yes.
Now, if y equal to sine x is a function, right, then definitely sine inverse x will exist for this. Right? So y equal to sine x is a function in what domain and range? Right? In minus pi by 2 to pi by 2. In domain, x-axis is known as domain, right? And its range is how much? What is the value of y? So the value of sine goes from 0 to 1 only. Right? Sine 0 is 0, sine 90 is 1. Right? We don't get 2 or 3. Okay. So y equal to sine x is a function in minus pi by 2, right? And its range is minus 1 and 1, right? Correct. So now coming to this inverse, I'll tell you how we create inverse or inverse graph. Okay. Just be very careful here. Are you hungry or something?
Yes.
Hello.
Sir. Sir.
Okay.
Sir.
Yeah.
Yes.
So y equal to sine x is a function in minus pi by 2, and minus 1 and 1. Okay. So definitely now inverse of this will exist. Right? Inverse function of sin x will exist. Okay. And so let me draw it here. Okay. So there is, how do we know that some point is inverse of this, right? So let's do a small exercise. Okay. It's not exercise, one example. So this is a line y equal to x. Okay. Y equal to x is a line. Okay. Now there is a point here. Suppose this point is here.
Yes.
This is 1, 2. Now it is 3. Okay. And this is 1, 2, 3. Okay. This is 1, 2, 3. Okay. And this is 1. Then this is 2. This is 3. Okay. So this point is 3, 1. 3, 1. Correct or not? Okay. So suppose this point is here. Okay. This is a point. Here to here is 3. Okay. So its reciprocal or its inverse will be the mirror image. Okay. So just understand like this. If it is A, right, and it's B, right, so its inverse will be in the opposite side of this line, y equal to x. Okay. So somewhere here. Somewhere here will exist, and the coordinates will change. So the coordinates will become 1 and 3. Okay. So this will be your inverse. Okay. This is how we calculate. So your A will become B here. So what is happening? Okay. A was having 3, so that became B here. Correct? And this B become A. Clear? Any doubt?
Yes.
Okay. So, okay. So I just told you how to find inverse, how to draw the graph. Okay.
Yes.
It's very important that we learn all the domain, range, and everything for all 6 trigonometric functions, and we should know how to draw it. Today we'll see only sine. Okay. Okay. Now, whatever we learned right now, based on that, let us draw the graph of sine inverse x. Okay. This is very important questions and it comes in exam. Did you know all these things, or I'm just teaching?
I use some of it. So.
Okay, some of these you knew. So I'm drawing like this. Right? Okay. So what did we decided? The domain and range is 0 to pi by 2. It is here,
Yes.
right? And it is here, something like that. Until here and here, this is y equal to sin x graph, right? So I need to find, right, the reciprocal of this, means inverse of this. So draw a line, y equal to x. This is a graph y equal to x, right? So this is the, what is this value? This is pi by 2. This one, right? And this value is 1, correct?
Yes.
So this value is 1. So the value of this coordinate of this will be pi by 2 comma 1, correct? Then what is my ultimate purpose? My different is like it's reciprocal, right? It's inverse should be existing in such a way, right, that it will, so it is A and B, right? So once you change it, what it will become?
1 comma pi by 2.
So it will become 1 comma pi by 2. So definitely one is x-axis, right? And pi by 2 is y-axis. So how will you neatly draw it in your pen and paper? We can draw it like this. We should be able to draw it. So this is your, right? So the other point will go like this, correct?
Yes.
Not that big since it is 1, right? And this is pi by 2. So this will be something like this. Like this. And this point is minus pi by 2 and 1, right? So the other point will become, so this point has become 1 comma pi by 2. Now this point is minus pi by 2 and minus 1, correct?
Yes.
So it is minus pi by 2 and minus 1. So the other point should go away from it, right?
Yes.
Something like this. So if you draw it neatly, it will be something like this. Yeah. I'll
Yes.
draw it in the next. So it will be minus 1 and pi by 2. Okay. So what did we learn here? No? So y equal to x graph is like this. It start from 0 goes right way, go less like this, right? Goes like this. Right? This is y equal to sin x. Right? So y equal to sin inverse x will be how much? Right?
It will basically be the same type of curve on the y-axis.
Yeah. No, it will go like this,
Yes.
away,
Yes.
right? And here also it will go like this. So very important, it comes in exam. Y equal to sin inverse x. Or you can say that it is the graph of sin inverse x. Okay. Getting right?
Yes, sir.
So how did we draw? Now you know how to draw. No need to remember. Okay. You should know the basic rule. If I have a graph, something like this, right? And my graph is like this. My graph is like this. It is going like this, right? You just draw a straight line here and change the coordinates. So for us, it will go like this and it will move away from here. Okay. So this one is for sin inverse x and this is for sin x. Okay. So if you're able to draw sin x, you will be easily able to remember sin inverse x. Now tell me which one is sin x and which one is sin inverse x.
Second one is sin inverse x and first one is sin x.
Yeah. Right. Now, it is very important to also know this. You'll be able to draw now without remembering. Okay. So what are domain and ranges, right? For sin x. So let me take this. I'll explain. Yeah. So when we draw now, so the telling domain is -1 to 1 and range is minus pi by 2 to pi by 2. Correct? We restricted the range and domain. Here, no? This is a curve. So one is this line, the other one is this line. Correct? So we are talking about this coordinate and this coordinate. So just see here. Right? This was pi by 2 and 1. Right? And this is minus pi by 2 and minus 1. Right? So right now what has happened? The curve has gone, the coordinates have changed. That much has happened. Right? So earlier in x-axis, what was there? Pi. Here pi by 2 is then, right? The coordinate of this was pi by 2 and 1. Right? Coordinate of this is pi by 2 and comma 1. But the coordinate of this is
1,
1 comma pi by 2, and this one is minus 1, right? Minus 1 pi by 2. It means this value is 1 now, Dheeraj,
yes,
and this value is minus 1, and this value is pi by 2, and this value is minus pi by 2. Now we can easily figure out what is its domain and range. Okay. So the domain for this is x-axis. Domain is always x-axis. Domain of what? Domain of sine inverse x.
yes,
It is equal to, in close bracket. Close bracket means it is, we are also counting that value. Right? So you will be taking 1 minute. Domain is x-axis. Right? So domain is minus 1 to 1. Minus 1 comma 1. Right? And range is tell me the range.
minus 5 to 2 by 2.
Yeah, it's minus pi by 2 to pi by 2. Right? So now we know how to draw the curve of sine inverse x. Okay. What is its domain? What is its range? Okay. Let me know if you did not understand anything. I'll explain.
I understood.
You understood, right? So you should know how to draw graph of sine x. Sine x graph passes from 0 and meets x-axis at pi. Right? Then again meets at 2 pi.
Yes,
We have seen here. Right? This is pi. This is 2 pi. Right? So I have considered this graph here to here. Right? And then we created a straight line and found its inverse. Right? So now in exam, even though they are giving you domain, they are giving you range, or they are giving you this figure and giving you the graph of sine inverse x, will you be able to do?
yes,
Okay. So sine inverse x domain is minus 1 by 1, minus 1 to 1, and range is it. So we understood this. Are you fine?
yes,
So today my plan was to explain everything, but I just took some more time, Dheeraj. Okay.
yes,
So I don't want to overburden you today. Maybe from next class, we'll do it very smoothly because your basics are clear now.
yes.
Hmm? Okay. Let me know what you did not understand and you want me to explain slowly, or some improvement you want.
No, sir.
Okay. It is better than your class teachers are telling, or
Yes,
hmm?
yes, yes,
So you should know what is sine inverse x. Okay. Sine inverse x is only defined from minus 1 to 1, and range is minus pi by 2 to pi by 2, and you should be able to uh, figure out how to draw the graph. Okay.
yes.
So I'm not giving any questions today, but next class onwards we'll do questions as well. Okay. Dheeraj,
Sir?
anything?
No, sir.
Okay. So next class we'll understand cos inverse x, tan, cot, sec, cosec, and after that we'll start doing questions. Okay, because
Yes.
it is very important. Do you understand each and every line? Because I gave my example, right? When I was child and so many my colleagues in IIT also, they were, because that time YouTube and things were not there. Okay. Right now you have so many teachers, so many things available. Okay. But you understand like how the concept has come, what is the meaning of domain and range, okay, and how it changes. Okay? It will help you. Okay.
Yes.
So I'll give you the recording, or I'll upload in YouTube. You can watch. Okay? But today, please try to draw sine inverse x, sin x, sine inverse x, domain and range. Okay. If you're facing any problem, just ping me in WhatsApp.
Yes.
Okay.
Yes.
Thank you, Dheeraj. Good night.
Thank you. Thank
We'll meet on day after tomorrow.
you. Yes. I'll
And
try to come at 7:30, sir.
no. So even though you're not able to do, okay, why your class is going 7:30? I mean, what is
Not
the, till what time your school is there?
7.
Till 7 school is there.
Yes, sir.
Oh, okay, got it. So are you eating after coming or you didn't eat?
I drank some juice.
Okay, you drank some juice. Fine.
Yes, sir.
So if 7:30 is not there, 7:45 is also fine. Okay.
Yes, sir.
Okay. Fine. Thanks,
Thank you.
Dheeraj. Yeah.
Bye, sir.
Bye.